functions can be they can be transformed. That's what transformations over and over and over again. This A, H, and K, those are called parameters. So be sure you don't forget the vocabulary. These are called the parameters. The changes to the equation are called parameters, and the transformation that these parameters cause to happen, that's what those changes, the things that it makes my graph do, the changes, those are called transformations. And here we've got three kinds. We've got translations, this is the more formal math word. The word that we're going to use probably most often is a shift. A dilation, we're going to use stretch and probably shrink. You can also use the word compression. And reflections. We'll usually use the more common word, maybe flip. So just be comfortable with any of those words, whether it's the more formal mathematic word, the formal mathematic word, translations, dilations, and reflections, or the more common everyday word, shift, shrink, stretch, compression, flip. So we are starting off with the parent function. This is the graph of the parent function right up here, y equals the absolute value of x, and we're going to shift it. Remember, we have two different kinds of functions, two different kinds of parameters. This one right here, the ones that are outside, this is an outside parameter, this is an outside parameter. Outside. Why? It is outside the absolute value bars. This one's outside. This parameter right here, the h, that's an inside parameter. Outside parameters always change the y. Outside always changes the y. Inside always changes the x. And that triangle that I'm drawing is the symbol for change. It changes the x values. So if it's changing the y value, that is a vertical change because verticals are y. So when the k right here is, since it's on the outside of the function, do you see how they're showing you right here? Here's the function, and then we're outside the function with either a plus or minus. So k is outside the function. That's why it's causing a vertical shift. And it behaves exactly the way we think. We see a plus sign at the end of the problem, like we have right here, y equals the absolute value of plus 3. That means that we're going to translate that graph 3 units up. So this vertex that was at 0, 0 is going to translate up 3 units, and it's now going to be at 0, 3. So the absolute value bars, and this is going to be really hard for me to draw. But you should go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I didn't do too bad. And this one, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I didn't do too terribly bad. I got off towards the end. So that's what that one looks like because we went up 3. Then we're going to have negative k's. When we have a negative k, it's going to do exactly what we think. It's going to go down. It's going to go down whatever the number is. So this one is going to go down to 4. And we would say it's been vertically shifted down 4. And it would look like this. Okay, so that is the transformation. Minus k makes it move down k units. Up 3 or up or plus k makes it shift up 3 units. Shifting it up and down, it doesn't say this right here, but we should add it. Shifting it up and down, vertical. Oh my goodness, it's leaving. Vertical shifts change the range. So if you have memorized that the range of an absolute value function, remember the domain is all real numbers, negative infinity to positive infinity, and that's always the truth. For range for the absolute value function, the parent function, we said it was started at 0 and went to infinity. So if you have that memorized, you also have to have memorized that if it has a vertical shift, then we're going to change the range. So the range after it's shifted vertically is always going to be wherever you shifted it. So it'll be your k value, comma, infinity, if it opens up. If it opens down, it'll be negative infinity to your k value. And we'll see some of those over here when we look at reflections. So the thing that you need to remember right now is that your range is going to change if we change our k value. So if we have a vertical shift, then we're affecting our range. If it opens up, the range will always be whatever your k value is to infinity. If it's facing down, then it'll be negative infinity and it'll stop at k. Okay, so the H values, the H values are the ones that are most missed, and I think that they're most missed because of this negative sign right here. If you don't remember that negative H if negative H is what you see, then H is really positive. So depending on what we see right here, notice we see right here on this problem right down here, we see a +2. That means that H is really -2. That's why we're shifting left. Because in the formula up here, it says that the minus sign is part of the formula. So if we don't see that minus sign, that means we really have x minus -2. That's where that plus sign comes from the fact that we have the minus that's in the formula and then we plugged in a -2. So you have to remember that what you see here is the opposite of what you're actually going to do. We see right here a -5. That means that H was a +5, and that's why we're shifting to the right. So for +2, we would shift the vertex to the left 2, and then my graph would look like this. And then for shifting it, when we see -5, -5 means we're shifting it to the right 5. So the vertex would move right there, and then I'd do rise 1, run 1, rise 1, run 1. Okay, so this is when X was +2, I went left. When I see X and it looks like X is X -5, that's really, H is really a +5, so we move to the right.